Hello YouTube, Happy New Year. I'm going to be assuming you're seeing this video before, no, actually after my PS5 repair video, so I won't go over the full introduction. But this is one of the projects I've had shelved for quite a long time. In front of you is a ThinkStation P310. I bought this bare bones kit for a total of $68, including shipping on eBay. And luckily I got a good model, and I could explain that in detail as I open the case up. But we're going to be doing a budget build, which will include a modern GPU, an SSD, a good amount of DDR4 memory, and a pretty decent CPU for the price. I'm going to try to target it. I try to target it around $200 to $250, and with the blend of components we have, it's not bad for what you get. So starting off, we have a ThinkStation P310 bare bones kit. This is based off the LGA 1151 socket and 6th gen core processors that include both the sticker here for regular i7 and the Xeon, I believe the E3-V5 series. We'll go over that more in detail when I show you the CPU. So the benefits of doing this is that you have everything, and luckily I'll go over why I got pretty lucky with this configuration once we open up the case up. But you get you get obviously the case, a power supply, and in our case, literally, we got also the CPU cooler, SATA cables, everything, and the better power supply, which is something I'll go into detail in a second. So let me go ahead and open the system up. Okay, got the system up and open, and let me go ahead and adjust the camera. Doing this live. Man, I thought this would be a little bit better than I was thinking, but it's pretty jank. But anyway, besides the point, as you can see, got a power supply. We even got the CPU cooler installed. When I bought this as a bare bones kit, I assumed I would get nothing really, basically just maybe the tower, the DVD drive, the power supply. But we also have the SATA cables that came with the system originally, so every little bit helps. As I said, here's the LGA 1151 socket. We have 4 DDR4 DIMM slots. This supports both DDR4 ECC and non-ECC memory. There are 4 PCIe Express slots, PCIe 3.0. One is a by 16 slot. This is a by 1, a by 1. I'm guessing this is a by 4 socket. Probably not PCIe Gen 3, but I'm 99% sure this top socket is PCIe Gen 3. Sorry, still have PS5 on the mind. But power supply is important. I lucked out. There are 2 models of power supply on this machine. So if you're looking to buy one of these to do yourself, you have to make sure you get the one that's 400 watts. The one that's 400 watts comes with a 6-pin PCIe power connector. Otherwise, the system comes with a 250 watt power supply, which won't be enough for those mid-range graphics cards. I'm thinking RX480, which we'll be using in this video, and something like a GTX 1060. Something that you only need a 6-pin PCIe power connector to power. We also have this weird bay. I don't really know what this is. Looks like some sort of expansion module. 2 drive bay sockets, and I believe this machine supports booting off NVMe drives if you had it situated on the PCIe bus. I don't see a M2 socket anywhere on the board. So the only bad side about this computer, it uses a proprietary power supply specification. You can see there are 3 connectors coming off the board. There is a Lenovo proprietary power connector here, your regular CPU 4-pin power connector here, and a PCI Express connector. The rest of these SATA cables come off the board, kind of like the ATX 12VO standard. So that's a little bit overview of the system. It's very compact, as you can tell. I mean, it's light. It looks kind of like a micro ATX motherboard. Probably isn't micro ATX motherboard, just with standard, non-standard power connectors. And there's 2 5.25-inch bays, 3.5-inch bay from the front panel, which is currently housed with a media card reader, which you could use. I mean, if you needed to, you could use these bays for more storage, preferably. Or if I were to do it, if you need more than just 2 3.5-inch bays, you could take 2 of these 5.25-inch bays and get a 3.5 and 2.5-inch bay adapter in each, or even a quad 2.5-inch bay adapter in here, and then run some sort of RAID card on the spare PCIe card. All right, enough rambling. Let's go ahead and show you the components that are going to be in this build. So I'll be back in just a second. All right, here are all the components I'll be using for this build and the associated prices I paid for them. Some of these prices you probably could get a little bit better on, especially the GPU. I'll explain that in a second. You know what? Let's start with the GPU because it's the biggest component. So I paid $104.80 for the GPU, and this is an 8 gig RX480, and it has one with the 6-pin power connector. If you needed to save some money, you could definitely go for 4 gig card. I might need to use this 8 gig card for another project too as well. So you could probably get a 4 gig card for maybe 60 to 70 bucks instead. All these totals include shipping as well. So I paid a little bit extra for this one. But if you're looking to save a little bit, definitely go 4 gig card or maybe an NVIDIA class card. These are dirt cheap. Someone probably mined Ethereum on this. So they're pretty cheap now. It's gotten actually a little cheaper since I ordered this. So that's going to be the first part of the build. Our second part is the CPU. I paid $32.51 for it. This is a Xeon E3-1270 V5. A name that just rolls right off the tongue. It's got a base clock of 3.6 gigahertz and a boost clock of 4 gigahertz. This is basically an i7 6700, but in Xeon form. It also supports ECC RAM, which we'll get to in just a second. So it's 4 cores, 8 threads. I would recommend not going with a i5 based one because those are only 4 cores and they don't have hyperthreading. It's good to have the 8 threads, especially in the modern threaded world that we live in. And reasons why we went with this and not a P900, or not a P300, I mean, is because Skylake, a little bit newer. It has all the requirements you need for Windows 11, besides it's technically an unsupported CPU. But you can run Windows 11 on this just fine. This has AVX, AVX2, and it should launch basically any modern game you want. So that's why we went with the 6th gen base core processors. You could go with a Haswell or even an Ivy Bridge CPU, but with Ivy Bridge, I'd stay away from them, or Sandy Bridge, because this is a prediction, but I'm going to guess that games are going to start to require AVX2 pretty soon, which is only on Haswell CPUs and newer. So 4th gen core, I would probably say is the minimum you want to strive for these days. On to the next component, we have our boot SSD. You could cut this in half if you have to. This is a 240 gig SSD, SATA 3. I paid $23.83 for it on Amazon. And it's Kingston. It's a cheap drive, probably DRAM-less, an A400. But it'll get the job done to be a boot drive for the OS, and which we will plan on installing Windows 11. So we'll use Windows 11 on this as the boot drive. And for our data drive, we have a 1 terabyte RE3. I paid $17 for this, and for both of these components, it's about $40 or so. You could probably cut both this in half. You got a 500 gig hard drive. Even if you need a hard drive, if you're good enough with 240 gigs on the SSD, you could get rid of this. But you could get some storage for your games and your storage for your OS, and you could make this a 500 gig drive and a 120 gig drive if you needed to cut down on some cost. Our last component, besides an optional one, is our RAM, because obviously we need this for the system to boot. This is 8 gig of PC2133 DDR4 ECC memory. You could tell it's ECC because it's got this middle chip in here for the error correction. And I got this for $25 for both sticks. If you needed to, you could probably get a single stick for about 10 bucks for 8 gig, but try to go for 16 these days, in my opinion. I don't think 8 gig is really cutting it for minimum these days, which is unfortunate. I remember when a few things, old man going on tangent, but I remember when CPUs were normally this size. This was kind of what surprises me, is that like, oh wow, this is a smaller size CPU, because I'm used to the new AMD and Intel CPUs just being giant as they added more cores. And when I bought my original Kronos from Mushkin SSD back in the early 2010s, it cost me about $130 for 120 gigs. So to get a 240 gig SSD for $20, times really have changed. And for memory too as well. I ran Windows XP, which was a 32-bit operating system, unless you had the 64-bit, which was based off Windows Server. But I remember being like, whoa, 3 gigs of RAM? That's a lot. And now I recommend 16 gigs as a minimum. Anyway, enough tangents. On to our next component. We have a AC7260 wireless plus Bluetooth. I'm pretty sure there's a header on there for Bluetooth. It's just a standard USB connection. Paid $16 for this. This is optional. I try to always include it on my builds because it's very helpful to have Wi-Fi and Bluetooth if you need to hook up any controller, or if your desktop tower is going to be somewhere where it's not convenient to have an Ethernet jack. So in total, for all these things, including the case and the power supply and the motherboard, we paid a total of $287.14 with my great handwriting. Like I said earlier, you can cut this down, drop the SSD if you need to 120 gig. You can even remove this. You can remove this. Keep the price down. You could probably get around $220, especially if you change up the GPU. If you're going to 4 gig RX480 or maybe a 470 or 460, you could get a lot more. You could get this number around to maybe like $200. But I feel like this is a pretty good blend to give you a good blend of components that you could also use so especially for when you're building an OEM system like this, you want to also buy some components that you could at least use in the future, like a video card, the SSD, the RAM, hard drive, probably not the RAM, depending on what kind of system you'd be buying. But a lot of these components you could still migrate to a newer build and have no issues in like a normal case with a normal motherboard. Say if you went with a AM4 based Ryzen system, I believe you could even reuse the RAM. You just need a new case, motherboard, power supply when they become hopefully more affordable. But anyway, enough rambling. Let me go ahead and get all the components installed in the case, and then I will show you the build. So I'll see you in a few. And here we are with all the components installed. Everything went smoothly except for one issue, which is oversight on my part. The GPU is a bit too long. So I have it installed in the system, obviously, but it blocks the front USB 3.0 connector. It's my handy flashlight. So it blocks also a couple of the SATA ports as well. It just fits in the case fine. And but if you were to use this GPU, you wouldn't be able to use the front 3.0 ports. So that is a bit of a bummer. For our testing purposes, I'm just gonna put this to the side for right now. We'll test the system as is. I have everything else installed. The RAM I installed according to the motherboard manual. It said to use the blue slots. CPU is installed. Wi-Fi cards installed. I had to splice into the media card front header in order to get some USB lanes. There's only 2 headers for USB on the motherboard. One is actually being used by this device, which is where the media card reader is, and also a 5.25-inch bay. That's one of those slim ones for optical ones. That's what this device thing is in here. So you can add an extra device here if you needed to. Maybe I'm guessing probably an SSD or a one of those slim optical drives, and then you can put more hard drives in this bay. I don't have the DVD drive hooked up. It's hooked up via power, but there's no SATA cable for it. I'm just going to leave that blank for now. I'll put a SATA cable in once I get a new GPU, as in like when I sell this machine, I will be putting a new GPU in here. Probably a 1063 gig card that's a little bit smaller. Then I can plug in the remaining SATA cables I need and the USB 3.0 front connections. So that's a little bit of an overview. It looks pretty clean in here. A little bit of wire over here, a wire mess, but it's not too bad. I've seen better and worse in OEM cases. But we'll go ahead and put the side panel on and we boot up the system. So I'll be right back. So here you are, booted into a Windows 10 install, as you can tell. Currently updating firmware. A little worried about this Intel management one. It seems to be stuck at 76%, but can minimize that for now. I went ahead and updated the BIOS on the machine already. It was running a BIOS from 2017, and it was having issues booting with the original RAM. Oops, that was a terrible noise I just made. With the original RAM I had tried putting in here. I don't know if these sticks work, so I thought, why not try updating the BIOS. I also tried this Vengeance stick. This is a 16 gig, 2400 megahertz module, but this one didn't work either. I do have some other crucial budget DIMMs that I put in there. I have an 8 gig stick in there currently working. So if I have to, I'll just use those two. But one of the quirks you need to find out about working with these older machines is that you can't plan for this, or you can plan for it, but sometimes it just doesn't work, like in my case. But that's why I'm here, to get this out of the way if you're looking to buy one of these systems. So make sure you get some RAM that works. Anyway, regardless of that, we have our Windows 10 installed, and I was just make sure all my oh man, that camera, that's not focusing well, is it? Oh, okay. Here, let's point down to here a little bit. So, gotta fix that on the screen. But anyway, I have the Bluetooth installed and working. Well, it looks like I did a good job splitting in that USB line into it, so that's good. Everything else seems to be good. Our RX480 is installed, and the TPM module, the discrete one, is actually 1.2, so I'm going to change that to the firmware TPM, which would be a 2.0 chip. So if you're wanting to run Windows 10 or Windows 11, I'd suggest using the firmware one instead, so you have 2.0 compliance. Also, there is NVMe support for this machine, which is interesting. I did not realize that. When I was in the BIOS, I saw that you could put it in a riser card and the 4X slot. So if you wanted NVMe, this is also an option on this machine. You just need to put the card into, or the NVMe drive into a PCIe card. All right, enough rambling right now. Let me go ahead and finish installing any firmware updates, shut the machine down, boot to the BIOS, get ready to install Windows 11, and I think I'll call it a day for now. It's been a while. It's been a while. So, all right, I'll see you guys in the BIOS. And into the BIOS we are. Let's go check out the system summary. We have our 16 gigs of memory now installed. I put in the other one of that crucial memory. It's technically 2666 megahertz, but the CPU can only support 2133, so that downclocked that. But this is working fine. Don't know what was up with my other memory. Maybe it was registered and not just ECC, and that could be causing issues. I don't know why the 16 gig DIMM didn't work either, but oh well. As long as I got it working, and we have our BIOS updated to the latest version, dated from 9/23/2022. Let's go check out some things. All right, just going through these columns, looking, everything seems to be fine. I like to tweak this a little bit, like I disable all the Pixie boot and network stacks. We have our top slot, which is by 16, then the other by 16 slot is by 4, and then the by 1 slots. Thunderbolt, like I said, there's Thunderbolt support on this if you had the proper hardware, but I do not on this one. Here's all the CPU information, fun stuff, right? Intel management, a bunch of other IDs. After last power, I like to keep it powered off. You know what? Let's put it back to the last state. Better thermal performance. Let's better do full speed. Nah, we can leave it on that. Back power on. That's all good. Security. Let's go to TCG. Let's change that to a. Can I not? Oh, do I have to set it as to disable? Oh, okay, and then I can change it. All right, there we go. Firmware TPM. Secure boot is on. Everything else looks pretty good. Startup C, if I were to go down here, we have the option for M2 NVMe. And I don't know where an M2 SATA card would be, but we do have M2 NVMe boot. If you do install an NVMe drive, I disable everything except for the SSD, and the actually uses the USB HDD. Sometimes they use the USB HDD or USB key, so I always try to make sure to enable both. We could leave these as is. CSM, I'll disable on this. We have no need to enable it. And that's it. My goal for tomorrow is to build a Windows 10 installer with Rufus. I mean, Windows 11 installer of Rufus, so I can install on a machine that technically doesn't support it. And then we'll benchmark some games. I'm only going to do a couple pretty modern ones. We'll do probably Call of Duty Warzone 2.0. And what's another recent game that's good at benchmarking? Maybe Cyberpunk. I'll play it more for benchmarking than actually play the game. But just to get an idea, you play the better games, or not the better games, but the more demanding games, so you have an idea of how the system would perform with less demanding games. But anyway, folks, I will see you guys tomorrow. Hello everyone, it's now day 2, and we're going to go ahead and install Windows 11 on our P310. In order to do so, we will need to download the ISO right from Microsoft. So here you go. I just Google Windows 11 download, brings you right to this Microsoft site. And we want to download the Windows 11 disk ISO edition. So you download the ISO, it'll ask you to select your language, and then once you have the ISO downloaded, you could go to Rufus. This is a tool that you could use to create bootable USB installers for basically any OS. So you want to download Rufus 3.21, and once it's downloaded, we could go to our downloads folder. And we could run Rufus. I'm using this on my second monitor, so I need to drag the windows over. I have a 32 gig USB flash drive already inserted into the machine, and we're going to select our disk image, and we're going to get the Windows 11 ISO. It's going to scan the image, and we can just leave all of these default,
and we're going to go hit start. And this is where you can remove certain limitations that Microsoft has created on Windows 11 installs. And you can leave the default where to remove the requirement for 4 gigs of RAM, secure boot, and CPM, and that will also allow you to install it on any hardware basically that is modern. I think you could go all the way back to Core 2 Quad or Core 2 Duo even if you want, but we could leave that as is. You could also select a whole bunch of other options if you want, but this is the minimum you need to get it to work on unsupported hardware. So we're going to hit OK, and it's going to ask us to wipe out our flash drive. If we hit OK again, and it will go ahead and build the installer. So it's going to take probably about 10-15 minutes, and once that's done, I'll be back onto the machine.
And here we are booted into the Windows 11 installer. I don't know why my camera really doesn't like filming this BenQ monitor. It's got some weird stuff going on in here, but it's just a solid blue screen on my end. So we could go ahead and hit next, install now. And then after this, I'm going to install the drivers, get the system up and running, install some games, and then I'll switch over to direct capture. So hopefully it will look a little bit better than this right now, and maybe sound a little bit better. So, okay, got to accept the Microsoft license. We'll do a custom install. You can do an in-place upgrade on unsupported hardware as well. I've done it on my laptop, and it works just fine. You just need to add a single line in the registry. It shows you how much of an artificial limitation it really is. Okay, blanked out my SSD. We have our hard drive as the top drive, our SSD is the bottom drive. I'm going to go ahead and hit next and just let it install. So it's probably going to take about maybe 10-15 minutes, and then I'll see you back in the operating system.
Okay, everyone, this is day 3. I've switched to direct capture. I'm using an EVGA XR1. It's a USB capture device. A helpful hint, if you ever need to capture something from it, you need to disable HDCP in your display settings in my case, in the AMD driver. So here we are on the desktop. Everything's running beautiful. I have no idea why Microsoft says this is an unsupported system for Windows 11, even though it works just fine, which just adds more fuel to the conspiracy fire that it's obviously them trying to push new PC sales. But here we have all the drivers installed. I have everything up to date, including I downloaded the latest AMD WQHL driver. I think it was dated December. And we installed some games. So I'm going to try Battlefield 2042, Call of Duty Modern Warfare Warzone 2.0, and also Doom Eternal. And I set up MSI Afterburner with River Tuna Statistics server. Let's go ahead and run some performance tests first. So I'm going to run a pass mark. And let's continue as in evaluation mode with this collect. And as soon as it's done, I'll go ahead and hit run benchmark. And let this run, and I'll see you at the results. Hello everyone, Post Cliff here, recording because I forgot to turn my mic on when filming this segment, or this back half of the segment, but as you can see, we got 61st percentile in our pass mark score, and our graphics and 3D mark basically carry the score, along with our memory mark, we got middle of the road. Our CPU, it's a little under 50%, but not bad. So overall, we built a relatively well-balanced system, as you can tell, held back a little bit by our old SSD, or low-tier SSD, and our low-tier hard drive. But 61st percentile, not bad if I do have to say myself. So on to a Cinebench test next. And our Cinebench R23 multi-core score just finished, and we got 5,004 points, puts us right above some of the lower end CPUs on their list they have here, and a little bit below, about thousands points below a 7700K, which really benefits from being on a slightly newer architecture and also having a much higher boost frequency. But as I said, this is a 4-core, 8-thread CPU, so we're not really looking for multi-core. Let's go to single-core and give it a try. So I'll go ahead and start the single-core test now. And our Cinebench R23 single-core scores, we actually are pretty good. We're in with some modern, heavily multi-threaded but lower clocked CPUs like the new Threadrippers and newer Intel Xeons, and even beating the first gen Ryzen in single-threaded performance, which is to be expected. I think they said the first gen Ryzen had IPC similar to in between Skylake and Haswell. So for gaming, it won't be that bad. And I hope to demonstrate that in the next section of this video where we actually go and play some games. So let me go ahead and start up some Call of Duty. Okay, we loaded into a game of Doom Eternal. We're playing this at 1080p with the Nightmare preset, so that's the second highest. I'm using an Xbox controller for this. I don't know the controls fully, but as you can see, we're averaging anywhere between 60 to 100 FPS right now, and that's with pretty high settings. And so the game looks pretty good. This is obviously 1080p on a 60 Hz monitor, so we don't have to worry about high refresh rates. But this is perfectly fine. Temps are pretty good. Our GPU is a little hot, but that's a reference cooler on that RX480. But we're getting great frame rate, and this is a 100% playable game. Like if I don't stop myself, I'll just keep playing right now because I'm having no issues. So, but just play a little bit more. Let's just play till I die. I think we're on Nightmare difficulty. So, yep, there we go. All right, so obviously this is a very well optimized game, so that's why we're getting such great frame rate on this title. But let me go ahead and try an unoptimized game like Battlefield 2042. So I'll be loading into that game now. So I did eventually load into a Battlefield 2042 game. I think I'm a little capped by the CPU, if you can't tell. Actually, everything's at 100%. This is still a very poorly optimized game for the PC. And I'm mostly running this on a mechanical drive, which I hear chugging desperately along to feed this, because my gun took a few seconds to load in after I spawned in. So, but, I mean, it is playable. This is 1080p at the medium details preset with no dynamic resolution scaling, so this is 1080p native, and I could probably drop the settings to get a little bit better performance. So I'm still surprised that people play this game. They butchered the franchise, but it makes for a good testing platform for older hardware that can technically run it, but can it gets stressed by how poorly optimized it is. So that's probably the only reason why I play this game. Which is a shame because I love the Battlefield franchise. Battlefield 4, Battlefield 3, Battlefield 2. So, I'm also not very good at this, so especially when it's jittering. You see those frame times where you see you see it right there where it just like kind of stops that stutter. It shows that our 1% woes on this game are not very good. If I was an advanced YouTuber and had this kind of charge. But here, let me see if I can play one more live. Or basically just die one more time. So I mean, it's a whoops. It never helps that I don't know the controls on the controller because I'm not sitting in front of the computer, or how do I put this? Where I have the computer right now, it's not like on a desk. So in order for me to use this direct capture, there I go. So all right, so that was fun 3 deaths, but This is a game that you could play on the system. Again, there's better games to play, so we'll just hopefully play one of those better games in Call of Duty. So go ahead and load up that one now. And last but not least, we've loaded into a Call of Duty match. I was expecting it to be a little bit better. We're playing at 1080p with the basic preset in 100% resolution scale. Um, I thought it was going to be a little bit better than this, but nah, I had to drop down the settings. And I turned FSR off because it looked terrible. I don't know if I had needed to tweak that, but it looked absolutely awful. I think it was the resolution, or it had the resolution at half, and then I was trying to upscale it, and it did not look good. So this was a pretty good compromise of quality and performance. But this is playable, obviously, you know. So there's maybe my noob tube. I haven't played COD in a while, but at least I do know the controls, so that helps. Don't remember my classes exactly though. But we were averaging, you know, between 30 and 40 FPS, so not bad. I assume if there's more or less going on, probably get better frame rates. Or if you change the settings, tweak it a little bit more, drop the resolution, like play it on a 720p monitor. But this is fine. See if I can play a little bit more, give everyone a good idea. See, at least I'm a little bit better this time around. The only issue is I don't have sound on. It's getting routed through my capture card, so I don't hear anything, which makes it a little difficult. It's a little bit of a part of the game. Do I have my, I don't remember what class this is. Oh, no. I'm blind. Got a kill, I think. I think I saw that. Got him. Alright, if I don't stop soon, I'm just gonna keep playing. So, I'm gonna do some bonus coverage. I guess I can call it bonus coverage, but I have the GTX 1060 6 gig card that's gonna be actually residing in this machine when I sell it. I'm gonna go ahead and put it in, and we'll try the exact same game, so just Call of Duty. So, let's shut down the computer, install that, and be back in a few. And here's the bonus footage. We are in the exact same game with the exact same settings, just different GPU. I have installed the GTX 1060 6 gig. It's an EVGA superclock model, and installed the latest drivers, and seems to be basically the same performance almost as the RX480 8 gig. So I'm not noticing too much, maybe a few more frames, but I guess you could go with either card in this system, and it'll be somewhat balanced. Both these entries are definitely playable, and like I said, this is like not on the most minimum settings, and at 1080p with native resolution, so you could always, you know, turn that down if you had to. But there you go. So I'm gonna wrap up this video after this, and then I'll go to my final thoughts and hopefully edit this abomination and get it on YouTube. So I will see you in my final thoughts video portion, I guess, whatever you want to call it.
Okay, so in conclusion, after seeing all the benchmarks and gaming performance, I have to say the ThinkStation P310 is an excellent value buy if you get it at the right price and the right model. You have to make sure to get the one with the bigger power supply because it is proprietary. And for $300 and for a middle of the road gaming computer, it's not really bad. You know, that's around the price of an Xbox Series S, and you get to use it obviously as a computer as well. In terms of the compute, in my thoughts on the computer, it's got a good amount of expandability internally, given the size limitation. I like the compact size as well. This is kind of like a micro ATX form factor. It's built pretty well. It's got plenty of USB and I/O ports on the back and front. And overall, I'd definitely recommend it. And if you couldn't tell, we got a bonus video. I'm going to be using this 10 or a bonus segment in this video where I actually use this GTX 1060 6 gig instead of the Radeon RX480, because this is what I'll be putting in the computer to sell it, because I'll actually be able to hook up the USB 3 front headers. So overall, I'd recommend it if you get it under a complete system with a decent GPU for about $250 to $300. And they, like I said, you get the higher wattage power supply. Make sure to put an SSD in it, and you're good to go. Obviously, you'll be limited by 4 cores, and for an upgrade path, you can't go past Skylake. You're stuck in Skylake, but it's still pretty good for the meantime. And it's got a few more years left of life in it, especially if you put Windows 11 on it. You don't have to worry about it going at end of life anytime soon. So, all right, everybody. So this is Cliff, and I will see you guys in the next one, I guess. So, thanks.